Hello everyone, welcome to lecture number 10 of integration series. In today's lecture, I'm going to take a previous KVPY question. This question was asked in the year 2017. Now this question is a very important question. The question is, let's say small n be a non-negative integer and it is given that I of n, which is dependent on this index, is given as integration from 0 to 1 e raised to power minus y raised to power n dy. Now we have to calculate the value of I of n upon n factorial summation n is varying from 1 to infinity. So let's start. So first of all, we'll focus on our objective. Our objective is to calculate the sum, that is summation I of n upon n factorial from n is varying from 1 to infinity. So let's say the sum is capital S, and as you put n is equal to 1, I'll get this as I of 1 upon 1 factorial, plus when you put n is equal to 2, you'll get this as I of 2 upon 2 factorial, plus I of 3 upon 3 factorial, and the sum goes on up to infinity. Now from here I got to know that I have to calculate I of 1, I of 2, I of 3 using this relation. This I of n, this index is given, and it is integration 0 to 1 e raised to power minus y raised to power of n d of y. Now here I'll be needing a relationship between I of 1, I of 2 and I of 3 and so on. So that means I'll be needing a reduction formula here. In order to calculate the reduction formula, I'll be using integration by parts. So let's say this is our second function, this is our first function. Here I'm applying integration by parts. So I of n will be equal to first function, that is y raised to power 1, into integration of second, that is minus e raised to power minus y, and the lower limit is 0, upper limit is 1, minus integration of differentiation of first. So differentiation of y raised to power of n is n y raised to power n minus 1 into e raised to power integration of second e raised to power minus y dy, and we'll get a corresponding negative. So negative negative is positive, I have adjusted here, and the lower limit is 0, upper limit is 1. Now I of n is equal to, when you put 1 here, you'll get minus 1 by e. It's quite visible. When you put 0 here using y, it will be 0. So minus 0 plus n times. Now if you focus here, for index n, y raised to power of n, the integral is I of n. Now for the index n minus 1, the integral will be I of n minus 1 simply. Now I'll take this on the other side. So I of n, we got I of n minus n times I of n minus 1 is equal to minus 1 by e. Now our objective is to calculate I of n upon n factorial. So I'll do one thing, I'll multiply this whole equation by 1 upon n factorial. So I'll get this as a reduction formula, that is I of n upon n factorial minus I of n minus 1 upon this n and n factorial will cancel out, and this will give me n minus 1 factorial in the denominator, and this is equal to minus 1 by e multiplied by n factorial. So using this reduction formula, I'll be calculating the sum in the next page. So in the previous slide, I've calculated this reduction formula. So from here, I'll be calculating the value of the sum. So let's say I'm putting n is equal to 1 here. So when I put n is equal to 1 here, I'll get this I of 1 upon 1 factorial minus I of I naught upon 0 factorial is equal to minus 1 by e into 1 factorial. So I'm keeping this as minus 1 upon e. Now when you put n is equal to 2, we'll get this as I of 2 upon 2 factorial minus I of 1 upon 1 factorial is equal to minus 1 by e into 2 factorial. Similarly, for n is equal to 3, I'll get this as I of 3 upon 3 factorial minus I of 2 upon 2 factorial is equal to minus 1 by e into 3 factorial, and this goes on up to infinity and is tending towards infinity. Now we'll be needing the sum of all of I divided by followed by factorial. Now if you add here, you'll see a telescopic series, but that's not I want. I want the sum of all i's divided by their respective factorial corresponding to this index. Now here I see, if I add here, I of 1 upon 1 factorial will cancel out with negative I of 1 upon 1 factorial. Similarly, I of 2 upon 2 factorial will cancel out with negative times of I of 2 upon 2 factorial. So I'll not get my desired sum. In order to get the desired sum, I'll do one thing here. I'll multiply the first equation by 1. I'll multiply the second equation by 2. Similarly, third equation by 3, and so on. It goes on. So I'll be getting this as, if I multiply this by 1, I'll get this as I of 1 by 1 factorial minus I naught, 0 factorial is 1. It is equal to minus 1 by e. Now when you multiply by 2 here, you'll get this as I2 divided by 2 factorial multiplied by 2 factorial, that is 1, minus, you will get this as twice I1 is equal to minus 1 upon e, because 2 factorial and 2 will cancel out. Similarly, if you multiply by 3 equation with, you will get this as I3 divided by 3 multiplied by 3 factorial will be 2 factorial, minus you will get this as 3I2 divided by 2 factorial is 2 here, is equal to minus 1 upon e into 2 factorial, again 3 multiplied by 3 factorial is 2 factorial here, and it goes on up to infinity. Now I'll show you why I have multiplied by 1, 2 and 3 in order to get the desired result in the next page. In the previous slide I got this result for n is equal to 1, that is I1 minus I0 is equal to minus 1 upon e. For n is equal to 2 I got this as I2 minus 2 of I1 is equal to minus 1 upon e. Similarly for n is equal to 3 and so on up to infinity using this reduction formula. So in the previous equation, you remember I multiplied the first equation by 1, similarly this equation by 2 and so on. For the third equation by 3 and corresponding to numbers I have multiplied in order to get my desired result. Now here I'll explain why I have multiplied this number in order to get the desired result. Now if you add all the equations, you will get this as I1 minus 2 of I1, so you will get this as negative times of I1. Now I can write this as I1 upon 1 factorial. Similarly, if you add this I2 minus 3 times of I2 divided by 2 factorial, so you will get this as minus times of I2 upon 2 factorial, because negative is there, so I've took negative outside. Similarly, if you add I3 divided by 2 factorial minus 4 I3 upon 3 factorial, you get this as I3 upon 3 factorial, that is with negative, so negative is outside, and I3 divided by 3 factorial. So if you follow up this trend, you will get this all the integrals with the index I4 upon 4 factorial, I5 upon 5 factorial, so on up to infinity. Minus 1 is remaining, that is minus I0. So I'll write here minus I0 is equal to, now let's calculate on the right hand side, that is minus 1 by e. So 1 by e is common here everywhere, so I'll take minus 1 by e common everywhere. Now the rest I'll write here, that is 1 plus, if you take minus 1 by e common from the second equation, 1. From the third equation it is 1 by 2 factorial plus 1 by 3 factorial, and it goes up to infinity. Now let's simplify this. So this we have taken as capital S, so this is our sum S with a negative sign, so this is equal to minus of S, and here you'll get S as minus I0, and this is equal to minus 1 by E. Now if you focus on this number is quite familiar with us, so I'll explain what is this number. So if you remember, e raised to power of x expansion, the expansion of e raised to power of x, it's valid for x belongs to R. So the expansion is 1 plus x square by 2 factorial plus x cube divided by 3 factorial, and it goes on up to infinity. Now if you focus on this number, when you put x is equal to 1 here, so you'll get e raised to power 1 as 1 plus 1 upon 2 factorial, 1 upon 3 factorial, and it goes on up to infinity. So this number indirectly it is written as e. So this is nothing but e. So from here I got this as minus s minus I0 is equal to e, and e will cancel out, I'll get this as minus 1. So using this equation I'm going to solve the value of s in the next slide. Now in the previous slide I got this equation minus s minus I of naught is equal to minus 1. So here I want to calculate s, so s will be equal to 1 minus I naught. Now in order to calculate the sum value s, that is s is summation of, if you remember, I of n upon n factorial, that is our motive, and n is varying from 1 to infinity. Now in order to calculate s, I'll be needing I naught, and so I naught I'll carry from here. So I naught will be, as soon as you put n is equal to 0 here, you will get on the right hand side integration from 0 to 1 e raised to power minus y, and y raised to power 0 is 1, so it is equal to 1, and d of y. So let's calculate I naught here. So I naught is equal to integration of e raised to power minus y is negative times e raised to power minus y, and the lower limit is here is 0, upper limit is 1. So negative I'll keep outside. If you put 1, you will get 1 by e, and if you put 0, you will get this as minus 1. So this is equal to minus 1 by e plus 1 I naught. So the value of s is equal to 1 minus 1 minus 1 by e. So 1 and 1 will cancel out, negative 1 by e is 1 by e. So our final answer is s is equal to 1 by e, and that's a good place to stop.